Hi everyone, let's solve July 1's LeetCode challenge question. So the question is fair distribution of, so I did July 1. Okay, July 1 was fair distribution of cookies. You are given let's read the question. You are given an integer array cookies where cookies I denotes the number of cookies in the ith pack. Okay, so there are in 0th pack there is 8 cookies, in 1st pack there is 15 cookies, 10 cookies in this pack, and 20 cookies in this pack. You are also given an integer k that denotes the number of children to distribute all the bags of cookies to. Okay, so I need to distribute all these cookies to 2 children. All the cookies in the same bag must go to the same child and cannot be split up. Okay, so if I want to, so there are 2 children, and if I want to distribute cookies from this bag, then 8 cookies should go to the same children. I cannot split cookies from the same bag. Okay, and the unfairness of a distribution is defined as the maximum total cookies obtained by a single child in the distribution. Unfairness of a distribution is defined as a maximum total cookies obtained by maximum. So return the minimum unfairness of all distributions. Unfairness obtained by a single child. Okay, I'm not sure what they're trying to say by minimum unfairness, but let's see. So in this example, 8 and 2, so 8 cookies will go to first child and second child. So 8 cookies will go to first children, right? And I need to distribute. So one optimal distribution is 8, 5, 18, and 10, 20. It means I will give 8, 15, and 8. So these bags to first child, and these bags to 10 and 20 bags to second child. Then what will be the total? Then total will be 8 to the 16, 16 to the 32, 31, and this will be 30. So it means 31 and 30, right? So I am trying to distribute these cookies to both child equally, but this is what I could get, and the answer would be the first child receives which is total 13 cookies, and the second child will be 40 cookies, and the unfairness of the distribution is maximum 31. Okay, so it can be shown that there is no distribution with an unfairness less than 31. Okay, I got this question now. It means that so the minimum unfairness of all distributions means that I need to find the optimal distribution. So this is the optimal distribution that I can get, and so there is no any distribution with unfairness less than 31. So I want to get the minimum unfairness of all distributions. So this is one possible distribution, right? This is one distribution, and another distribution might have been like first child would get 8, 15, 8, and 20, and second child would get 20. So at that point the unfairness would be 31 plus 10, 41. So since this is less, so that is why this is the answer. So I need to find a distribution where one child gets, where I will distribute the cookies in such a way that the maximum cookies that the child get is the minimum of all distributions. Okay, so how can I solve this question? Let's try with another example. here say there are 3 child, right? 1 2 3 child, and first child will get, let me try to solve this. So if first child gets 6, second child gets since there are 3 children, so first of all there are 3 children. How can I distribute all these cookies among 3 children so that everyone will get a fair share? 6, and if I get 6 to first children, then it will be 613. The sum is 6, so I don't want to get 2 to this one and 2 here, and then 4 here, and 1 here, and 2 here, 3 4 5 6 7 8. So if we see at this distribution, the maximum cookies that a single child has got is 8. So the answer would be 8 at this, for this distribution. Unfairness would be 8, and for this distribution maybe I could do better. Like suppose if I get 6 to one children and 1 to another children and 3 to another children. This is really tricky question. 1 to these children, 3 to these children, and 2. How can I distribute it equally? Okay, I'll just try a brute force method. Okay, let's come up with the brute force method first. So okay, I'm trying to find a brute force solution. Okay, so first of all I'll get 6 to this first child, and 1 to this child, 3 to the third child. Or should I continue? Okay, I'll give 6 to this child and 1 to second child, 3 to this child as well, because the maximum is already 6, right? So I will keep on giving it to second child until it will become equal or less than 6. So 1 3 and then 2, so 3 4 5 6. Now I will give to this child, so 1 3 2 I give it there, right? So now it will be 2 4 4 5 6. Okay, now that's fine. So this is 6 3 4 5 6 4 5 6. Now I have what left? After 2 4 1 and 2 are left. So yeah, it's now like, because every child there are 6 numbers. Now I cannot, if I give 6 to 1, then another something will be 8. So this will be 7 and this will be 8. So the distribution becomes similar to this one, because the unfairness was 8 for this child as well, for this distribution as well, and even for this distribution the unfairness is 8. What can I do then? 1 6 1 2 1 3 2. For first child, any other distribution possible. Like one child will always have 6, right? And another child, suppose if I give 1 to second child, and suppose I give 4 to second child, I'll start from the maximum. So first of all, I'm just trying to sort it. 6, 4, 3, 2, 2, 2, 1, 1. I'm sorting because I think that it would be easier for me to keep the highest at first, so that I can balance it out at last. So 6, 4, 6, 4, 3, 2, 2. Oh, I'm already 11 minutes over. 6, 4, 3, 2, 2, 2, 1, 1, right? Okay. So 6, 4, I've given 6 to one child. Like there is no any other option. And 4 to another child. And 3 to another child. And then there are 2 again. So I will keep 2 to the minimum one. 3, 4, 5. And then there is 2 and again, so I'll give 2 to another one, and there is 2 again, so I'll give 2 to the minimum one. 3, 4, 5, 6, 7, and there is 2 1 again. So I mean, this is already 3, 4, 5, 6, 7. This is 4, 5, 6. This is 6. So if I give 1 1, then it will be 7. Okay. So if I am distributing this way, then the answer is 7. The minimum fairness is 7. I mean the 3, 4, 5, 6, 7, and here also 4, 5, 6, 7, here also 6, 7. So is this the algorithm? Does it make sense? Like my algorithm is that I will sort it first. I'm sorting it because it will be, I'm sorting it because I think it will be easier for me to distribute the bigger one first, because if I put the bigger one first, then it will be easier for me to distribute the smaller one at last. So my algorithm is just first of all sort sort in descending order, and then after sorting in descending order, keep on distributing cookies, keep on distributing bags to children. So while distributing, distribute, always distribute back to the smallest one, to the child with lowest number of cookies. So this is my algorithm, right? Here also I distribute 6, 4, 3, and then I distributed 2, so 3, 4, 5, and then I distributed 2 again here, and then I distributed 2 again here, and then I distributed 1 and 1. Does this make sense? Will this work for all kind of cases? Let me think about it. Let me think about this logic, if it works or not. Yeah, so I am let me think silently for a second, for a minute, to think about if this logic works or not. So I'm distributing, sorting in descending order, and then I'm distributing bags to all the child. So I distribute bags to this child and another child, this to another child, to another child, another child, another child, another child, another child. So Is there a way that I can distribute so yeah, 6 4 3 2 2 1. Is there a way that I can distribute like 6 and then 3 randomly? Like if I distribute it randomly and not in order, then it would be even more difficult to find out who gets the list, right? Because I want to distribute it fairly. So 6 4 one gets 6 and I get 4, one gets 3. I'm trying to distribute all the cookies fairly. Okay, I'm trying to distribute all the cookies fairly so that everyone will get the equally. Let me look at another example. Oh, there is no another example. So let me try to build example then. Suppose there is 10 and 4. So there is 10 and 18 and then 100. Then what do I do? In this case also, like 100 will go to one child, right? And 18 will go to another child. 10 will go to another child, right? And then there are 3 children and I'll get 100, 10 and 10 to another one child. And then so which bag would I give another? Will I give it 1 or will I give the highest one? I think that I will give the highest one because it will be easier for me to balance at last. Okay, yeah, I have thought about it and I think that this might work. I'm not 100% sure, but this might work. Okay, so let me just write the code and then try to see if this works or not. Actually, I should have thought about edge cases scenarios, but I did not do that anyway. Yeah, so I will think about edge cases after writing the code at this time. Okay, let's look at constraints. Cookies.length is so cookies there will be at least 2 cookies and there will be 8 and cookies I, so there will be at least 1 cookie in the bag, up to it can go up to 10 to the power 5, and there will be at least 2 children. Okay, so what I was doing is, first of all, cookies.sort a b a minus b. Like I think that this will work, right? It's been a long time since I have not done this. So 3 5 1, then a dot sort a b a minus b. Okay, this is sorting in descending order. Yeah, ascending order, or I need descending order. It is b minus a. I hope that this will change cookies, right? So if I say a is equal to 2 1 2 1 3 and a dot sort a b b minus a, then a had changed. Yeah, okay, now after sorting, what I'm trying to do is I'm trying to put 2 different bags, right? So I need a sum. Let sum is equal to I need sum for distribution. Distribution will be equal to let distribution will be equal to new array. So since there are k children, so first of all there will be all everyone will get 0, right? The sum is 0. And then I'm going through the cookies now for constant as of cookies. What I'm trying to do here is I'm trying to give this as to the lowest sum, right? So how would I do that? I'm trying to, I think that I should also keep index for lowest for the minimum, so that I will add it to the minimum, right? Lowest index is equal to 0. But will that work though? Okay, first of all, I'll just do it brute force. So here what I want to do is I want to find the minimum, right? So so distribution lowest child, with lowest each method minimum of distribution sum. So this is my lowest child, and what is the lowest child index? Where is it? It is in distribution sum dot index of child lowest, right? So what I'll do is distribution sum child lowest index is equal to, I'm adding it, now I'm adding this to as, right? So yeah, distribute back to the child with lowest number of cookies, right? So I found so this is the child with lowest number of cookies, right? So that's why I distributed the bag here, and at last I want to return the maximum. Who got the maximum? Right, so let's do logical. First of all, I sorted it in descending order, then first of all I distributed, like the sum is 0 for all the child, and then I went through all the bags. I got the which children has the lowest. So this is the lowest, this is the child with lowest number of cookies, and then I added to it, and then at last I returned the maximum. Output is none. Oh, method max dot actually, because I need to spread it as well. Output is 33, expected is 31. Output is 33. So even for this case it did not work. Let me see. So there is first child and second child, right? And if I am sorting, then it will be 20, 15, 10, 20, 15, 10, 8, 8, right? So first of all I'll give both are 0, so first of all I'll give 20, and then since this is the lowest, right, so I'll add it to 15, and then since this is the lowest, right, so I will add 10 here, so it will be 25, or I can just say 15, 10, and then I'll give 8 here, so this is the lowest, and then I need to keep another 8, right? So this is 28 and this is 28, so I need to keep 8 here. Oh no, 1 is 8, 15, 8. No, this is not a good solution then. Here I am not distributing it properly. So this sorting was not a good idea. 20, 15, 10, 8 comma 15 comma 8. So how to come up with that distribution then? How to come up with the distribution like 8 comma 15 comma 8? And another one is 10 and 20. I think I need a hint. Backtracking. Ooh. This is a recursion problem. Attempting all possible distribution of cookies, but that will not be efficient. I was thinking about that, but okay, anyway, like, so the hint I got is look at all the possible combinations. Okay, yeah. I thought that it would be too expensive, so that's why I did not think about it. I saw that someone mentioned greedy solution also in the comments, but instead of greedy solution, I want to do a backtracking because I think that would be easier for now. So how to do a backtracking solution now? First of all, so there are this many cookies and k is equal to 2. I thought that this problem was a simple string solution, string quotient. Anyway, so first of all, 8, 15, 10, 28 k is equal to 2, right? So first of all, there are 2 children, so I would want to give 8 to first children, and then if I give 8 to first children and then if I give 8 to first children, then I'll give 15 to another children. So first branch is children 1 and second branch is children 2. Okay. I did not see the solution properly. I just saw the hint only that it can be done with backtracking by generating all the possible combinations. So I am also not sure about the backtracking solution. So let's see the approach how I can do it with backtracking. I'm thinking that first child, second child, and if I give this to first child, then so 8 is already gone at this point. So I need to distribute 15 at this point. What if I distribute 15 to first child and then if I distribute 15 to so here I'm distributing 8 to first child and second child does not get anything. Here I'm trying to generate all the possible cases. Okay, here I am distributing 8 to first child and here I am distributing 15 to first child. Another point, I have 15, so I think here I can say 8 to second child. Here 15 to first child and another position there will 15 to second child. Okay, I think that is a good branch. Right, so first decision is I'll give it for every number I'll give this to first child and the second decision would be the second child. This 15 I'll give to first child and this would be second child. But what if there are 3 children? Then will there be 3 branches? There should be 3 branches at every position, right? Because I can give that cookie to any children. So this is for first child and this is for second child and this one is for I'm giving it to third child and the second one is 1. Sorry, second one is 1. So here I'm giving 1 to first child and here I'm giving 1 to second child and here I'm giving 1 to third child. So yeah, if I am looking at this path, then I gave 6 to one child, 1 to one child, and if I go to this path, then I gave 6 to first child and I give 1 to second child. I think this way there will be path for all the possible combinations. So when I reach at last, I need to find the, I guess, suppose if I just add 1 and 6 and 1 only, 6, 1 and 3 only, then it would be, so this I'm giving this. So first let me just think in silence, like it is difficult for me to think and speak at the same time, so I'll just think for 1 minute in silence to figure the approach. Okay. 6, 1, 6, 3, 6, 1, 6, 2, 6, this is first child. Okay, I think that I got it. So here we can see that every path is a possible distribution path. So when I reach at the end of the path, when I reach at the leaf node, then I will know what is the fairness for that distribution, right? So I will also keep a minimum fairness variable and see if that path gives me the minimum, then I will update the minimum. So okay, let's start. uh, Let minimum will be equal to, I guess, 0 in the beginning. So minimum fairness, so this is my minimum fairness, and I'm going DFS for every possible, you know, for every possible value. So I guess the sums would be distribution new array k that fill 0. So this will always be there. So distribution sum will always be there because at last I need to find the sum. And so function DFS, and then now I need to what I need to do is I need to do it for all the at every position, right? At every position there will be 3 times. There will be for const for I is equal to 0, I is less than k, I plus plus. So for at every position there will be k number of branches. So distribution sum so let's look at first position. In the beginning there will be 0 0 0, right? And so distribution sum's value will be 0 0 0, and if I call DFS in the beginning, so DFS will be I guess I should call distribution sum comma 0, right? Because I want to look at the first cookie. I'm giving away the first cookies. So will be distribution sum comma, you know what, actually anyway I'll just look at, so okay, this is my index, cookie index. Cookie position, so I'm at position 6, so I need to distribute 6 to the children. So I need to distribute cookie position, I need to distribute it to the children, right? So I will distribute in such a way that everyone, like all the 3 ways. So what should I do is distribution sum so cookie position is cookie sum is equal to cookies at cookie position, right? So this is the cookie that I want to divide, and I'll also look at what happens if I divide to first child. I also look at what happens when I divide when I give it to second child, and I also look at what happens when I give it to third child. So for that, I'm just iterating over all the child and looking distribution sum I plus I think that I should also pass the number of name of child, I. So this is the child. Let child is equal to 0, child is less than k, and child plus plus. So this is the child that I'm passing. Okay, distributed this to this child. And do I need a distribution sum? I don't think so, because distribution sum, it always changes. I mean, even if I pass or not, this will change. Right? Let's see. So child comma I'm trying to pass cookie position. So cookie position will be cookie position plus 1, because I want to look at another child at next time. So here I can see so this is a cookie sum, and then this is a child that I want to change, right? So distribution sum and child will be equal to cookie sum, because this is a child that I'm distributing cookie sum to at this point. What I'm thinking is, so at this point distribution sum will be 6 comma 1 comma 0 at this position, okay, and it will be 9 comma 1 comma 0, right? This will be my distribution sum. But when I go back, then the distribution sum, it should be, this would have been 0 again, right? Sorry. So this would be deleted, isn't it? Because I'm going back. So it means that after I'm done with all the children, and once I'm going back, then I should delete this one. So at last I need to delete it. Minus. So 3 1. So suppose if I'm at this 1 2 position, then I'll look at all the children, and after I'm done with all the children, then I want to when I'm going back to 6 1, then I want to delete this one. So that's what I did here. Some child will be equal to it minus cookie sum, because I added it here. Yeah, that's what I did here. I'm just backtracking at this position. And at last also, so if, because I'm always adding, right? So how will I know if I've got, so if cookie position is equal to cookies dot length, then it means that I pressed at end, right? So at that point what I will do is I'll just update minimum fairness. First of all, I'll get fairness of that distribution by doing math.maximum of distribution sum, and at last I will do math.minimum of fairness distribution comma minimum fairness. It means that this would be equal to maximum value actually. Numbers at positive infinity or something like that. Numbers at positive infinity, yeah. Number that okay, so this will be too much, so it will always be minimum, will always be, and then return. I'm just thinking about the first scenario now. So here I'm always adding, right? So I'll get a child, I'll get the cookie position. What I can do is I can do this one. For cookie position it's 0 in the beginning. For child is equal to 0, child is less than k, child plus plus. I'll just do it child 0 in the beginning. Child 0, child 1, child 2. So yeah. So when I'm going to 0, then this will add. I am just hoping that this will work. Okay, return. I am not return this minimum fairness at last. Time limit exceeded for this one. Because there are 8 different. Anyway, they like, so 2 test cases have not passed. What did I do wrong? Let's see. Start cookie 0 to child 0, cookie 0 to child 1, cookie 0 to child 2, cookie 1 to child 0, cookie 1 to child 1. Update the answer with result. As a result, we backtrack to next possible distribution by distributing the last cookie to child 1 and repeat the process. No cookies left for child 1 and child 2. Stop. Okay. 1, 2. To optimize. Okay, so what can I do for optimization? We can use an early stop technique. Consider the same example in the image below. Suppose that we have already distributed the first 2 cookies to child 0. When we come to the last cookies, would you continue the recursion process by distributing to any child? Suppose that we have already distributed the first 2 cookies to child 0. Child 1 and child 2 will require at least 2 cookies, and at this point we only have 1 cookie remaining. No matter how we distribute this last cookie, it will lead to an invalid distribution. Therefore, discard this path and not proceed further. Okay. Got it. So what I should do is to optimize this process. I don't need to do it when I am so I gave it to first child, and then I gave this to first child as well. So if what we are trying to do here is, suppose this cookies is 6, 1 and 3, right? And then suppose the cookies are 6, 1, 3, 4, 5, 6, then there will be one branch, right, where I will give cookies. So cookies to first child only. So 6, 1, 3, 4. So I have distributed 4 cookies to the first child already, and there are just 2 cookies left. So I have distributed 4 cookies to first child already, and there are still 2 cookies left. It means that since I've already distributed 4 cookies to first child and there are just 2 cookies left, or I have distributed 5 cookies to first child already and there are just 1 cookie left, but there are 2 children left. It means that I will not be able to do a valid distribution, right? So at that point I will stop. It means count to first children. I have got up to this count, right? 0, 1, 2, 3, 4. There will be 5 cookies, right? I've already distributed 5 cookies, and I've already distributed 5 cookies to that children, and I still have, and I have one cookie left. 1 cookie left, but I have 2 children left. One cookie left, 2 children left. So that's not good, right? I have not distributed to 2 children at all, and there is only 1 cookie left. So if number of cookies left, number of bags left is less than number of children left, then stop, right? So 6, 1, 3, 4, 5, and there is only 1 children left. Number of bags, there is only 1 left. Number of children left is 2. Yeah, at that point. So child is equal to 0. Let's see if they are also doing the same. To implement the OLE, we will introduce a parameter named 0 count that represents the number of children without a cookie. Number of children left without a cookie. So this means number of children without a cookie, okay? And during the backtracking process, if we have fewer undistributed cookies, number of bags left means fewer number of, if it is less than number of children without cookie, then it means that children will always end up with no cookie. At this point we'll terminate the distribution. Yeah, they are also doing the same. So let's do that. So how will we find number of children without cookie? We'll find that by zero count. Oh, so yeah, if current j is equals to 0. How will I know if that if how will I find number of children without cookie? That's the question. So I think I can find the number of children without cookie by looking at this, maybe, because I'm distributing, because I know, right, the children I'm distributing to. Let's do let zero count. First of all, number of children without cookie is 0. Right? And then no, first of all, number of cookies without cookies k. So if so here I know that I'm distributing child to, right? So if child is not equal to 0, I need to go to the washroom. What should I do? Okay, I'll just look at the solution and then complete it. Current j is equals to 0. Iterate through distribute and for each child j. For each child j, increment distribute j by cookie I. If distribute I is 0 before the distribution, then decrement 0 count by 1. Oh, okay. Increment distribute j by cookie I. If distribute I is 0 before the distribution, decrement 0 count by 1. So if is equal to 0, then number of cookies, right? So this is what they are saying, number of children without cookie, because I'm about to add it, but it was 0 before. It was 0 before, it means that child hasn't got any cookie before and about to get one. So number of children without cookie minus minus. So now I'm what to keep. So it means that if then return, then another one is if if cookie position. So how will I know how many cookies are left? Constant I mean number of bags left. Number of bags left will be equal to cookies dot length minus cookie position, I think. So if there are 3 cookies, 1 2 3, and if I am already at 0 1, then if I is equal to 1 0 1, then the answer will be 3 minus 1 is equal to 2. Two cookies left. If number of bags left is if number of bags is left less than number of children without cookie, then there is no I don't need to return it. Oh, the time limit is still exceeding. It is still exceeding. Number of bags left is less than number of children without cookie. Constant number of bags left is equal to, this is fine, right? I think this is fine, because otherwise it would not is less than number of children without cookie. Then return. That is too much. It is working, but it is taking a long time. Oh, okay. And so I should not just return, but I should also stop. I mean to say that if it is -1, right, then if I'm returning this, if number of bags is less than number of children without cookie, if I've already reached at this position and I'm returning from here, so it will not even check other children as well, right? This is similar, this also, but oh, it got accepted. So what I was missing is I did not I was not updating number of children without cookie at last, because this is a backtracking, so I need to update this as well, because I was removing cookies on at last. Okay, thank you for watching, everyone. Bye.